Now let's have a look at the other type of question where you are given the derivative function, you know, the graph of the first derivative, and then we're trying to sketch the original function. So we still sort of follow the same idea, and we try to do the sign diagrams for f dash of x and f double dash of x. So if I try to do a sign diagram for f dash of x, I need the critical points for the f dash of x. Critical points for f dash of x are the ones where it's actually cutting the x-axis, because this is a graph for f dash of x. So as you can see, I have these three x-intercepts of the f dash of x. Those are the critical points for the f dash of x. So I have -6, -1, and 5, and then I will be able to put in the signs in there as well. As you can see, when x is smaller than -6, my f dash of x is a negative number, then becomes a positive, it's a negative, and then it's a positive. When I try to do my sign diagram, I try to align these coordinates with the original graph, so that later it will be easier for me to sketch my graph onto the original place. Now I'm trying to do one for f double dash of x. Now what I'm trying to do, I'm trying to find the critical points on the second derivative. The critical points on the second derivative, well, I'm looking for the points where the second derivative is a 0. And then the second derivative is essentially describing the gradient of the tangents on the first derivative graph. So I'm essentially looking for the places where the first derivative is having a horizontal tangent, because those are the places where the derivative of the f dash x is a 0, and the derivative of f dash x is essentially the second derivative. So if I look for those points where it's got a horizontal tangent, those are the stationary points of the f dash x. And these are the points, I don't know what they are. Let's say that's an A and that's a B. So I will have my two critical points A and B there. And what I know is I can sort of work out the sign of my second derivative by looking at how the gradient is changing on my first derivative. So as you can see, when x is smaller than a, the gradient of this first derivative function is a positive number because it's going up. So I know the second derivative must be a positive number on that time, on that region. And then in between a and b, as you can see, the first derivative graph is decreasing. So the gradient of the tangents to this curve in between a and b will be a negative number, and therefore this part will be a positive because the graph is going up. Now, how am I going to use these two information to help me sketch the original fx? Now, the first derivative is telling you whether the original graph is going up or down. So from here, what I can see is it's going down and going up. And you should have a local minimum at -6. And then it's going up, going down. It will have a local maxima at -1. And then it's going down, going up. It will have a negative. It will have a local minimum at x equals 5. That's what you will know where the stationary points are in the original function by looking at the first derivative. And then let's have a look what the second derivative tells you. The second derivative tells you what the curvature looks like in those regions. So when x is smaller than a, what I know is it should be a convex. And then when it's in between a and b, the original graph should be a concave. And then when it's greater than b, it should have a convex there. Okay, now we can go back to sketch the whole thing. Oops. So by looking at the original graph, what it should like is it should be going down first. It should be going down, and then it will reach a local minimum at x equals -6, like that. And then it's going to go up, still maintain that convex shape, but then when it reaches that x equals a, it will still be going up, however it changes its curvature into concave. And then it's keeping that concave shape until it reaches a local maxima at -1. And then it keeps going, and then it will start to go down while still maintaining that concaving shape until it's reached that B where it's changed its curvature into a convex. And then it's going to reach a local minimum at 5. And then it will start to go up. While it's going up, it's still maintaining that convex curvature. And this is what the graph looks like. This will be the f of x, the original f of x. So you draw the sign diagram and use the sign diagram to sort of get the shape and the tendency of this of the original graph, and then try and map this back to what it looks like. Now note one thing, your graph, it could be a vertical translation of what I'm showing here. And we can't really locate where exactly the graph is, but what we do know is all these features, these stationary points, these points of inflections, that's what we know. So as long as you have these features correct, this graph is correct.